In this example, the engineering team has been challenged to improve the performance of this router while maintaining the cutting accuracy of this design. One of the ideas the team is considering is reducing the amount of weight of the bracket that connects to the Z-axis subassembly. This will allow the team to change to a motor with lower torque, which will reduce the cost of the design. In the past, the design team would take their best guess as to where they might be able to reduce weight, and before simulation software, they would create a prototype and physically test it. This iterative process would repeat itself, and even with simulation software involved, it was still a very repetitive try-and-see approach to reducing the weight. Rather than iterate on revision after revision, the team is going to utilize technology that will enable them to better predict what areas of the design are critical to the functional requirements of the part, and which material can be removed and still function to specification. Ultimately, the purpose of this predictive method is to maximize the performance of their components with minimum weight. In addition, the engineer was able to offload the time-consuming simulation computations to the cloud, which let them set up different loading conditions to solve multiple studies simultaneously to ensure they test out different solutions early in the development process. With the suggested geometry now driving the shape of the bracket, the team can utilize the integrated solution to make changes to the CAD geometry and run further analyses to ensure the changes meet the design requirements without any rework to set up the analysis. The real advantage here is the power of the information presented to the engineers so that they can make the most informed decisions that makes the most sense for their business. The team can now decide to use a lower torque motor, which will reduce the cost of the design and increase the profit of the product for the business. The future of making things is now, and the technology to achieve the outcomes demonstrated are available today. In this example, you saw a predictive design approach using the shape optimization capabilities inside Fusion 360. The team collaborated from different geographical locations with Fusion 360, which managed the version history and enabled the reuse of existing designs. Since the data is stored in the cloud, all team members were able to participate on key design decisions anywhere on any device. But that is just the start. Fusion 360 is the complete solution from concept all the way to production. The team programmed their part for the Haas machine to produce a prototype to test the form, fit, and function. Ultimately, the team delivered on the goal of improving the product's performance by reducing the weight of the component by 21%, which allowed them to downsize the motor to a lower torque without sacrificing performance, quality, or cutting accuracy of the router machine.